World at War. It wasn't simply the numbers or strategy. It was a battle of technology. The Enigma machine, widely used by Germans in the Second World War, air, land and sea, the Axis power used hundreds of Enigma machines for the military's top-secret communications. Attack at dawn was one of the commands the Germans learned to enforce using coded letters, and it took thousands of lives of allies because code breakers didn't stand a chance to make sense of those words intercepted by radio. It was known to be unbreakable even for someone in possession of the machine. In theory, the number of possible settings for the Enigma, including every component, is 3.28 times 10 to the power of 114. That is more than the number of atoms in the universe, 10 to the power of 80. In practice by Germany, this number was greatly reduced due to their preferred operating procedures to sustain consistency. This yielded 1.58 times 10 to the power of 20 possible settings for the other power to figure out. It would take twice the age of the universe for 100,000 operators if they were to each check one setting every second. And in comes a young and talented British mathematician, Alan Turing. Born the 23rd of June 1912 to an upper-middle-class family, Turing studied at King's College and Cambridge University and became a Fellow of King's at the age of 24. Some of his early pieces of work and achievements include probability theory, central limit theorem, and publishing uncomputable numbers. He was especially good at connecting so-called useless logic to mathematical logic and practical computation. At an early age, Turing had deep understandings about programmability and had ideas for a universal Turing machine which would have the ability to perform programmed algorithms and be reprogrammed. He is now recognized by many specialized in the fields of mathematics and computer science as the father of modern computers. It was Turing's trust in programmable machines that led to the invention of the Bombe machine, a counter to Enigma. With his understandings of algorithms, Turing created the concept of cribs and menus with the help of routing texts. A crib is a sequence of letters from a plain text that can be matched one-to-one with the sum letters of the ciphertext, and a menu is a diagram showing the potential links between letters. Turing knew the existence of stackers meant that a letter X is always plugged to alpha, alpha being the unknown partner. He figured that if alpha is correctly found for X, then the remaining letters and their stacker partners can be easily found using some of the captured radio messages. A sequence of scramblers at their respective rotor positions can test for the unknown letter alpha. If alpha is pressed on the keyboard and comes back unchanged after the electrical voltage goes through the entire sequence, then it is stackered to X. If alpha is pressed but comes back not being alpha, then alpha is not stackered to X, and a different letter will be tried. Since there is only 26 possible alphas, the true alpha can be determined. Turing applied a new strategy, and that is to use a voltage feedback loop to enable conclusions obtained from previous trials to be used as a new hypothesis for stacker partners, and the Bombe machine would stop when it has figured out some settings. With help from another mathematician, Gordon Welchman, the diagonal board was implemented into the second version of Bombe. It increased Bombe's efficiency as the electrical system increased the number of hypotheses rejected from each trial. In 18 minutes, the Bombe could find out rotor orders, rotor starting positions, and stacker partners, which are essential parts for decoding Enigma. This provided 18 hours of top-secret intelligence to the Allies and greatly helped their victory. It was estimated that the invention of Bombe shortened the war by at least 2 years. Turing showed the potential of computers through mathematical logic and his Turing machine. He even had the Turing test to examine the level of intelligence of computers compared to humans. He died at the young age of 41 years old, but he influenced the modern way of thinking with links between numbers and computation, brains versus machines, and his knowledge of computability long lasts today, and his stories continue to be told, as in the limitation game recently.